Good afternoon to all. Myself Vishnu Priya, currently working as an assistant professor in Department of ECA at SNS College of Technology. Today, this video we discussed about the microwave perceived devices. In this microwave perceived devices, further we discussed about the scattering parameters and its waveguides. Already previous video we see about the scattering parameters and properties. In this video discussed about the scattering parameters and its waveguides. How this scattering parameters involved in this waveguides of microwave frequencies communication. In this directional coupler, the waveguides is passing through between the microwave devices. That devices are directional coupler, isolator, circulator and attenuator. First device we discussed about the directional coupler in S matrix. How this S parameters related to the directional coupler directional coupler operations. In this directional coupler it has the 4 ports, so it has the 4 ports network, and port 1 and port 2, port 3, port 4. That port 1 and port 2 is called as primary waveguide, and port 3 and port 4 is called as secondary waveguide. In this directional coupler, the wave is given to the port 1, the wave is going to the port 2 and the port 4. The output is get to the port 2 and port 4. In this port 3 is temporarily closed, that is the back EMF is stored in this place. So this is the directional coupler. How to form S matrix in this directional coupler means S equal to this is the formation of S matrix, 4 cross 4 matrix, 0 0. The diagonal elements are 0, remaining elements S1 2 0 S1 3. Based on the waveguides, that is signal flows through the input to output side. What we give the input side means that is called as the input port, and we get the output at the which port, that is called as output port, and that at that time the auxiliary waveguide is also performed. That's why we consider this another port. This basic performance we form this S matrix formula. Next, this is the S matrix in directional coupler. This is the derivation. In directional coupler, all the ports are completely matched. The diagonal elements are 0. Already we see. Next, the no coupling between port 1 and port 3 means the port 2 and port 4. What means the S11 and S31 equal to S24 equal to S42. That is called as coupling between port 1 and port. Consequently, the matrix of a directional coupler becomes, this is the directional coupler, the S matrix representation. We can reduce means the zero property of the S matrix. So the S11, the conjugate we applied, that only zero matrix is used. This is the the directional coupler S matrix equation. Next, we see about the device using this circulator. How to the S matrix represent by using this circulator. The circulator is also have 4 ports networks. In the 4 ports, the waves are traversed by the circulator, that is clockwise direction. So this clockwise direction, what means the input is given to the one port means how to perform the waveguides, and the output get it to the output port. S equal to 0, S1 to S1. So this means 4 port circulator. This is the microwave circulator is a multi-port waveguide function which wave can flow only from nth port, that is to n plus 1th port in the one direction. In general, there are multiple circulators are available. Most commonly used circulator, we have 4 port circulators mainly we use in this microwave devices. So it is used in this only clockwise direction. Does not used in the anti-clockwise directions. So this is a 4-port circulator. This is the S matrix representation of 4-port circulator. Next, we see about the isolator. Isolator means nothing but the waveguide passing through the only one direction. In reverse direction, it will not be get the waveguide of the output. This is the S matrix of isolators. S out 0, S out 1. This is a 2-port networks. That's why we use represent by this matrix in 2 cross 2 matrix. Next, we see about the attenuator device. In this attenuator or passive electronic components used to reduce the power of an electrical signal without distorting its waveform. They are commonly used in various applications including radio station, laboratory testing and circuit design and fiber optic communication systems. So in this attenuator, it is also called as 2-port network. In this 2-port network, the S parameters are represented by the B1 equal to S11. Already we know B1 is called what is A1 is called reflected wave and incident wave. S1 is called as S parameter matrix. So this is the attenuation. Next, we see about what is the applications of S parameters and its waveguides means. First one is quantum field theory and practical physics. In quantum field theory and practical, they use this S matrix as fundamental tool for calculating cross-sectional of practical scatterings. Decay rates or unstable particles and studying the formation of bound states. This is the main purpose of quantum field theory and practical physics. Next, we used in the microwave RF engineering. Already we know in microwave devices we use this isolator, circulator and a direction coupler. S parameters are crucial in this field for characterizing networks and devices. So this main we use this S parameter characterizing network, which port, 2-port network, 3-port network or n-port network. It is characterizing networks and devices, which devices it performs, and designing circuits like amplifiers and filters and achieving impedance matching. This is the main applications of microwave RF engineering. In atomic physics, S matrix theory helps understand ionization excitation process in strong fields. So it describes high harmonic generation and attosecond physics. These modifications for relativistic effects in extremely strong fields. This is the applications of all attenuators and circulators, and this is some waveguides of the applications.